Hi, my name is Matin Aldavoud, and today I'm going to be doing basically the second part of my extra credit assignment for Math 8A with Dr. Weisbart's class. Basically going to be touching on a concept that I had a little bit of a problem with, but been starting to teach myself a little bit more, and I feel a little bit more confident. So it's completing the square with relation to ellipse equations. Ellipse equations. Alright, so basically, before starting off, we need to understand what the standard form of an ellipse is exactly. And I'll just write that over here. The standard form of an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. And this is standard form. Just always, I'm going to keep that right there as a reference because it's pretty important. So sometimes we're not going to be able to get an equation pretty much in standard form. So what we're going to have to do is complete the square to solve it. So let's start off with an example. Let's say 4x squared plus y squared minus 32x minus 14 y plus 49 equals 0. First of all, we can notice immediately that there's no variable next to this number over here, so we can pretty much just subtract it. So just subtract 49 from this side and bring it to this side, so there'll be a negative 49 on that side. And with one quick motion, I'm just going to pretty much group my variables as well, because bring my x's with my x's and my y's with my y's. So let's just do that. 4x squared minus 32x, leave a blank because we're going to be completing the square, plus y squared minus 14y, another blank, equals negative 49. Alright, so what we want to do next is pretty much make it easy on ourselves. We deserve to make it easy on ourselves. So let's just factor out anything we can in this equation. I notice immediately that I can factor out a 4 here, and I will do so right now. So bring that 4 out. You're left with x squared minus 8x. Again, we're going to leave that blank. Plus, and then we can't factor anything out here, so y squared minus 14y. Close that up. Leave that blank again. It's very important. Minus 49. So, okay, leave that with negative 49. Now, what we want to do is complete the square. So, we do that by dividing our b over here, which is negative 8, by 2. Divide that by 2, we would get negative 4. And then square that, we would get a positive 16. And over here, divide that by 2, we'd get negative 7. Square that, we get positive 49. And we're not done yet. What we have to do now is understand what we do to this side, we have to do to that side. So what a lot of people will get confused with is they'll just probably add 16 the way you add 49 here. And it's correct to add 49 here because there's nothing outside of the parentheses. There's a 4 outside here because we factored that out. So what we have to do is get 16 times 4, 24. So we would add 64 to this side because we multiply that, and then there's nothing outside this one, so then we add 49. These two cross out, so essentially we're just left with positive 64 on this side. Now that we have these two polynomials, we can pretty much break them down into their basic forms. So what let's just bring that over here. We can bring that down to 4x minus 4, square that, plus y minus 7 squared. And again, we're going to bring that, so equals 64. And so we're not done yet. We can see over here in our standard form, there needs to be a 1 and at our equal sign. So easy way to do this is we can divide everything by 64. And that'll leave us with 1 up here and 16 down here. So that would bring that down. 16 plus, let's see, y minus 7 squared over 64. And of course those cancel out and we get 1. And now we can look, we can recap. We brought this confusing problem over here, pretty much made that into standard form, so now you can see it checks out right there. Now, with this being said, what we can do now is graph it. Graphing so much is much easier compared to finding this form, so I'm going to be stopping right there, but essentially this is what really tripped me up a lot, and it was really annoying, but I finally got the hang of it, and I'm proud to say that it's pretty simple now. So yeah, again, thanks for watching. This is for Dr. Weisbart's Math 8A class, and yeah, have a good night.